I'm going to be explaining how to solve number 25, 26, and 27. So first, looking at number 25, the best way to start is by drawing a diagram. And we can see from the problem that it tells us that the magnetic field of the Earth is pointing 66.5 degrees below the horizontal, and that the bacteria has a magnetic dipole moment that is straight up and exactly perpendicular to the surface of the Earth. From what I just explained, this diagram can be created. So right here is the angle 66.5, and then this is the dipole moment pointing straight up. So all together, that creates an angle of 90 degrees plus 66.5 degrees, which is 156.5 degrees. Now we can use the equation for torque to solve for torque. So for that, we need to know the magnetic dipole moment, the magnitude of the magnetic field, and the angle, which we just found before. So from the problem, it tells us that the magnetic dipole moment is 10 to the negative 16, and that the magnitude of the magnetic field is 52.5. So this right here is all the information from the problem that I just stated. The only difference is that we have to take the magnitude of the magnetic field from microteslas to teslas. So this is the number we get for that. And then using this equation, we plug it all in, and we get torque is equal to 2.09 times 10 to the negative 21 Newton meters. For question 26, it is important to first look at a diagram like this, which is displaying the North Pole and the South Pole. This N represents the geographical North Pole, and this S represents the geographical South Pole. And for magnetic-wise, the South Pole is here and the North Pole is here, and we can see how the field lines go. And by understanding this diagram, it will help us create a diagram that is helpful for the question. So based off of the first diagram and the information from the problem, we can then come up with a diagram of how this bacteria looks before the torque has occurred. So we see that the magnetic dipole moment is pointing up, and the magnetic field is pointing down at an angle. And from here, we can draw that this is the geographical North Pole, geographical South Pole, magnetic South Pole, magnetic North Pole, and the field lines for the North Pole are all pointing down in this direction. If this is the bacteria with its North Pole and its South Pole, we know that its magnetic dipole moment is towards the north, the magnetic north, so it is going to point this way. This diagram now displays what happens once the torque has occurred. So the torque is going to move in this direction, spin it until it stops, and like we saw as I drew down here before, it's pointing in towards the north in the direction of its magnetic dipole moment. So if we basically take how it was here, apply it to it being spun, the dipole will always align with the local magnetic field, pointing down this way, and as we can see from the diagram, it will then swim in the direction that its North Pole points. For problem 27, we're going to take the same concepts that we learned from the last problem and apply them to this problem. So we're now in the southern hemisphere, so it's the same concept as the northern hemisphere, just the other direction. So the field lines will now be pointing up. This is the southern dipole, the geographical one, northern geographical, magnetic, and this is the bacteria with its North Pole pointing towards the magnetic North Pole, as so. This diagram shows once the bacteria is aligned with the Earth's magnetic field. So we can see it went from here to aligning with the Earth's magnetic field, which is pointing toward the north, and so its dipole moment will point to the north and upwards. And to answer the question based on this diagram, we see that bacteria will not survive because it will swim upwards, aligning with the Earth's magnetic field, but this is away from the low oxygen environment, which is down below, and it can only survive in this low oxygen environment.